Power MOSFETs. In the previous video, we have seen the BJT, bipolar junction transistor, which is a current control device. The collector current IC is going to depend upon the base current IB. These two are depends on the current gain beta. Beta is going to influence the junction temperature. There is a disadvantage of secondary breakdown. Secondary breakdown results from the current flow to a small portion of the base, producing localized hotspots, resulting in high current concentration. The current concentration may cause defects in the transistor structure, and this secondary breakdown occurs at certain combinations of voltage, current, and time. And this is basically energy dependent phenomena. The power
used in the
MOSFETs
applications
are
of
voltage controlled devices and requires only a small input current. The switching speed is very high. The switching times are nanoseconds. Power MOSFETs low power high frequency converters, and they don't have the problem of secondary breakdown. However, MOSFET have the problems of electrostatic discharging and requires special care in handling. In addition, it is relatively difficult to protect them under short circuit fault conditions. Depending on the structure, power MOSFETs are two types, that is depletion type, secondly enhancement type. In these two types, that is N type and P type. Similarly, here also N type and P type. N-channel depletion type power MOSFET is formed on P-type silicon substrate, P-type substrate with two heavily doped N plus silicon low resistance connections. Gate is isolated from the channel by a thin oxide layer. That is metal substrate. MOSFETs have three terminals, namely the source, gate, and drain. Substrate is normally connected to the source terminal. This is a drain terminal. And resistance RD, and this is VDD plus and minus. This is a gate voltage VGS, and this VGS may be a positive or a negative. And this is the structure of N-channel depletion type power MOSFET. Source, drain, this is gate VDD plus or minus RD, this is VGS plus or minus symbol. When VGS is negative, that negative supply is given to the gate, then what happens? The negative charge, and N-type material is also having the negative charge, that is nothing but electrons. So they repel each other, then the electrons turns to move away from the gate, and there will be a formation of depletion layer, which is not going to allow the flow of current from the drain to source. That means IDS is going to decrease. If this voltage is made enough, deflection layer is going to increase and the channel is going to close, then IDS will become 0. And that voltage VGS is known as a pinch off voltage represented by VP. If that negative voltage is enough to block the current from the drain to source by increasing the resistance in the channel, is known as pinch off voltage. If VGS is positive, the positive charge at the gate signal and the electrons are negative in the N channel, they are attracted each other, then the electrons move nearer to the gate, then this channel is going to open up, or else the free electrons are available in the N channel so that the current can flow from the drain to the source. The resistance in the channel area, drain and source RDS is going to decrease. Then IDS starts increasing. This is how the N-channel depletion type power MOSFET is going to work. If it is a P-channel depletion type power MOSFET, then the main substance is N-type and the channel is P-negative and this highly doped P-type material. And in the symbol, the direction is opposite. Current flows source to drain. This is ID for P-type. P-channel deflection type MOSFET, the polarities of VDS, IDS and VGS are reversed. In enhancement type power MOSFETs, there is no physical channel present in that. Since it is N-channel enhancement, these are the N-type materials, N positive, P-type substrate. Signal is VGS, a positive and a negative, positive and negative. This is the structure of N-channel enhancement type power MOSFET, and the symbol, since there is no channel, this is a dotted end, is ID. VDD is positive, negative, and this is VGS, so positive and a negative. When VGS is positive, an induced voltage will attract the electrons from the P substrate and accumulate them at the surface beneath the oxide layer. If VGS is greater than or equal to threshold voltage VT, a sufficient number of electrons are accumulated to form a virtual N-channel and the current flows from the drain to source. And below this threshold voltage, there is no channel in between drain and source, so no current flows. Similarly, when VGS is negative, it's not going to attain the VT, then the channel is closed and there is no conduction of current. This is N-channel enhancement power MOSFET. If you replace the P-type with N-type, and here doped ones N-type with P-type without a physical channel, and here the directions are in opposite and the voltages also opposite. Since the substrate is changed, N-channel will become a P-channel, as well as the directions of VDS, IDS, VGS are reversed for P-channel enhancement type of MOSFET.